Good afternoon, everybody, and welcome to this special event, a one-of-a-kind team-up between two apparently unlikely partners, the Museum of Science in Boston and the National WWII Museum in New Orleans. Skies over D-Day. My name is Talia. I'm with the Museum of Science in Boston. I use she, her pronouns, and I am going to be your moderator today, which means I'm going to be fielding questions and comments through the Q&A box here in the Zoom webinar. If you are joining us from Facebook, we're very happy to have you, but unfortunately we will not be able to see any questions or comments that come in through that, that service. But if you are here in the Zoom webinar and you would like to ask a question or make a comment or respond to a question from one of our presenters, you can do that using the Q&A box, which will either be at the bottom or top of your screen, depending on how you are watching this. If you would like to see captions, those are also available. There is a button labeled closed captions either at the bottom or top of your screen, again, depending on how you're looking at it or what you're watching on. And if you click on that and select show subtitles, you will be able to see captions for this presentation. But for now, I'm going to ask our two presenters to unmute their cameras and introduce themselves.
Hi, everyone. My name is Leah, and I am the STEM programs coordinator with the National WWII Museum, and I prefer she, her pronouns. I'll be one of your facilitators today.
Hi, everybody. My name is Katie. My pronouns are she and her, and I'm an educator from the Museum of Science in Boston. We're very excited to bring the stars to you today and add a little bit of history in there as well. So I'm just going to get us started by sharing my screen and telling you a little bit about the program I'm going to be using today, because you can also download it if you're interested. So it's a program called Stellarium. If you'd like to download it, you can go to stellarium.org, stellarium.org. And this is the web page that will come up. And if you use Windows or Mac or even Linux, you can download Stellarium and use it yourself. It's totally free, totally open source. There's also a web version, so if you prefer not to download anything, you don't have to. You can just use the web version as well. It does have some limitations, but it's still pretty awesome. All right, so let me go ahead and get us started here. So this is what it looks like. If you were to open Stellarium, some of the default settings are a little bit different than what I have here, but just some of the basic controls of this program. If you come over to the left here, you can set your location and your time. So this window will pop up if you hit location, and then there's a big long list so that you can view the night sky from anywhere on the Earth. There's a whole bunch of different cities and towns in this list. If you don't find your city or town, you can actually just input your latitude and longitude and add your spot. Latitude and longitude, those are the coordinates that we use for mapping things on the surface of the Earth, for finding a geographic location. So those are two coordinates that you can find if you look it up, if your town is not in this list. Something else that's really cool about this program is that you can change where you're viewing. So right now I have it set to Earth because we're going to be viewing from Earth, but you can actually change it to any of the planets or moons or even some asteroids and satellites. So lots of cool things there. And then you can also change the date and time. So you can go thousands of years in the past or in the future, or you can set it to your current time and location. But this whole program simulates the night sky as it actually is at any given point in time and also from anywhere. So that's just a little bit of the basics about Stellarium. If you download it, you can play around with it on your own. It's fairly simple to use, so I encourage everybody to do that if you'd like to. All right, so let's go ahead and get started talking about the skies over D-Day. So I have this set to viewing from the English Channel. So the Allied troops, D-Day, first of all, happened on June 6th, 1944, and it was the Allied invasion of the beaches of Normandy. So they started from Britain at 10:30 p.m. on June 5th, 1944, and landed on the beaches of Normandy for the invasion at 6:30 in the morning, or most of the troops did. So this happened over the course of the night. And so the stars that we're looking at right now are the stars that would have been seen from somewhere along the English Channel, which is about 50 degrees north in latitude, at midnight. So this was kind of when they were already on their way over. Now the issue is, during that time, the weather was really bad. So if they were looking up at the stars, they wouldn't have seen any of the stars. The original planned invasion was supposed to happen a day before, but the weather was also really bad on the 5th. So they decided to change it to the 6th. And even then, the weather was really bad. But if they had delayed it even longer, they would have had to wait a whole other month in order to start the invasion. So the reason for that has to do with one celestial object in particular, and you can see it right now. It's very bright over here in the southern part of the sky. It is the moon. So if we click on the moon, I can zoom in. And now I'm going to ask you, what phase of the moon is this? And if you have an answer, you can type it into the Q&A. If you know it, if you don't know it, you can put a question mark, because if we knew everything in science, then we wouldn't have science at all.
All right. We've got a few people mentioning a full moon. Somebody else calling it a whole moon.
Yeah, that's correct. So it is a full moon, and that was really important for the invasion, because the moonlight from the full moon could be used to help folks navigate through the water, especially the aviators. So the people in the planes could use the light from the moon throughout the night to guide them without using any kind of artificial lights. To stay stealthy. It was also important that the moon was full because of the tides. So when there's a full moon, the low tide is at around sunrise. And so they wanted low tide during that time so they could destroy any of the kind of German obstacles that were on the shores of the beaches. And also any of the landing craft that would take the troops onto the shores of the beaches of Normandy could beach themselves, and then the rising tides afterwards would make it so that the landing craft could go back into the water easily, so nothing was stranded there. So the moon was really important. Even though they wouldn't have been able to see any of the stars, the moon played a really big role. Now, I want to talk about some of the constellations that would have been used during this time for celestial navigation. In general, after World War II, a lot of new technologies came out, new navigational technologies, because celestial navigation proved to be a little bit unreliable just because of the weather during the war, and also there were so many young, inexperienced military service people that just couldn't learn celestial navigation quick enough, because it's complicated. There's a whole lot of stuff that goes into it. So it wasn't super practical. And so after the war, a lot of new technologies came out to help with navigation. But I will show you some of the constellations that were used for navigation. So if we're looking in the north and we look up, there is a group of stars. There are 7 stars in the shape of a giant spoon. They're very bright stars. So we've got 1, 2, 3 stars in the handle, and 1, 2, 3, 4 in the bowl. Does anybody know what this group of stars is called?
Got some people mentioning a dipper.
Yes.
Big Dipper specifically.
Yes, that is correct. So this is the Big Dipper. Very bright group of stars. It's really easy to spot, even if you're from a light polluted area. All the stars are very bright, and so I can connect the dots so you can see it a bit better. You will also notice that it's just a part of the constellation Ursa Major. So the Big Dipper alone is not a constellation. It's a part of this entire one, which is, believe it or not, supposed to be a bear. So if you were thinking it looks nothing like a bear, you're not alone. The constellations that I'm talking about today are the mostly Greek and Roman constellations, but there are versions for all different cultures all around the world. So these are by no means the only ones. But this is Ursa Major, the Great Bear. I always like to start with this constellation when I'm looking up at the night sky because it's easy to find and you can use it to find another very famous constellation. So if we take the two end stars of the Big Dipper and we stretch them in this direction, it will bring us to a very important star, very famous star right here. So if you go 5 times that distance, you will run into this star. So does anybody know what star that is? And I'll give you a hint by showing you the horizon and what direction we're looking.
Oh, some people didn't even need the hint. We've already got answers saying North Star.
Yes, exactly. This is the North Star, also known as Polaris. And the North Star is the end of the Little Dipper, or Ursa Minor, which is the little bear. It's very cute. It has a very long tail. Both of these bears have very long tails. Maybe there was a species of space bear that had a really long tail. I don't know. But the North Star is really, really important to celestial navigation. So if you compare it to some of the stars around it, it's not particularly big or bright or really cool looking by any means. But why is the North Star so famous and important?
Remember, you can always put a question mark if you're not sure, because it's important to know what you do not know. We do have some people putting question marks. We also have other people saying it's important because it always points north.
Yes, that's correct. It's always in the north. So there are no east or west stars because the stars over the course of a day change position because the earth rotates. So if we think about the sun rising in the east and setting in the west, that's because the earth spins. It's not because the sun is actually traveling across the sky. The same thing with the stars. The stars look like they move over the course of a night because the Earth is spinning. So this star, the North Star, happens to align perfectly with Earth's axis of rotation, which means as the Earth spins, all of the stars look like they are rotating around that point in the sky. So this always stays in the same position. And that makes it great for navigation because if you can measure the distance from the horizon to the North Star, wherever you are, if you're, in the Northern Hemisphere at least, if you can measure that distance, then you can find your latitude. So if you're out at sea and you don't really have much to go by, you're going to look up at the stars and you can find your latitude that way. There are also ways to find your longitude. That has to do more with timekeeping because whatever time it is related to your longitude, which is kind of a whole cool thing on its own. So the North Star and both of these constellations were used frequently for navigation. If we come over to the kind of east-southeastern part of the sky, we'll find 3 very bright stars that make up a group called the Summer Triangle. And this group of stars is actually also known as the Navigator's Triangle because these stars were also used for navigation. The reason being that they're so bright. Even if you're looking from a misty or light polluted area, these stars are very bright. And so their positions in the sky are well recorded. And so they were used a lot for navigation. So the first star we have here is Vega, and it's part of the constellation of Lyra the Lyre. And it just looks like a little parallelogram, maybe a juice box or something like that. But it's supposed to be a lyre. And I don't mean like a liar, pants on fire kind of lyre. I'm talking about a U-shaped harp. So this is what it's supposed to look like. That's totally what you all saw, I'm sure. But this constellation is actually one of my favorites because it has a really cool deep sky object. So if we zoom in, if you have a pair of binoculars or a telescope, you can actually zoom in and see, well, I guess you wouldn't be zooming in real life, but you'd be able to see this deep sky object, which is a nebula that formed after a star died. So that's just one reason that this constellation is really awesome. Besides the fact that Vega is a star that you might know from the novel or movie Contact, if you're a fan of that as well. Okay, so that's Vega, the first star in the triangle. We come over here to Deneb, which is part of Cygnus the Swan. Now, this constellation actually kind of looks like what it's supposed to be. And Deneb is just a really cool star on its own because even though so Vega and Deneb, they look similar in brightness, but Vega is so much closer than Deneb is. Vega is only about 25 light years away, whereas Deneb is closer to 2,500 light years away. So if it's that much farther and it's still just as bright almost, what do you think Deneb is like as a star?
And remember, question mark is always a fair answer if you're not sure. But we do have some people commenting that it must be quite huge. It must be really shiny.
Yeah, those are both correct. It's going to be really big and really bright. That is absolutely correct. So even though when we're looking up at the stars, it almost feels like all the stars are the same distance away because they're just so far that you can't tell which ones are farther and closer just by looking at them. So Deneb is a perfect example of when we look up at the sky, we're not always seeing everything, right? All right, and the last star in the Navigator's Triangle, or the Summer Triangle, is down here. It's called Altair, and it is part of Aquila the Eagle. And a fun fact about Altair is that it's actually not spherical, or it's not perfectly spherical. It's actually shaped more like a donut because it spins really fast. So the middle parts kind of bow outward a little bit. So it's just a fun fact about Altair. So these stars, these constellations, in addition to Ursa Major and Ursa Minor over here, they were all very prominent navigational constellations. There's another one over here in the south called Scorpius the Scorpion. And since we're so high in latitude, this constellation doesn't get above the horizon very much. It does a little bit, but it doesn't get very high up in the sky. But this constellation is also used a lot in celestial navigation for more equatorial regions. So places like Hawaii and other nations in Polynesia use this constellation, but they don't refer to it as the Scorpion. They call it Maui's Hook. So if you've seen Moana, you're probably already a little bit familiar with it, but this was also used for Polynesian navigations. So there are so many constellations in the sky. I wish I could go over all of them and tell you how to find all of them, but unfortunately we don't have too much time. So I just want to talk a little bit more about celestial navigation itself and the tools that are used for it. So I mentioned measuring the distance from the horizon to the North Star. A tool you can use to do that is called a sextant. And so that's how a lot of people out in the middle of the ocean would have found their latitude. Aviators as well use sextants, but they don't always have a clear view of the horizon, right? Because they could be above the clouds, they could just be really high up and not have a good idea. So they had an altered tool called a bubble sextant. And what a bubble sextant did was it had a little air bubble with some fluid around it that would act like a level, like a carpenter's level, to provide a artificial horizon. And so they were able to tell their latitude and where they were using one of these tools. And this was actually used a lot during the war by fighter planes that needed to accurately measure where they needed to drop bombs, for example. That was really important to have that accurately plotted out. Something else that I found in my research for this program about celestial navigation during the war was that there was a training cockpit that was used as a flight simulator, and it was combined with a planetarium. So pilots, trainees would go into this flight simulator, and they could use both all the controls that they would in an airplane, and they would have the simulated night sky as well. So that was a really cool thing. That's called the Link Celestial Navigation Trainer. And some of the first people to use it were actually a group of women called the Women Accepted for Voluntary Emergency Service, which is really awesome too. And they actually trained a lot of the young pilots in celestial navigation in the kind of aviation setting, which was awesome. All right, so I think that is about it for me. I'm going to turn it over to Leah now. She's gonna tell you all about this really cool activity that you can do at home that will help show you some of the constellations and how to find them.
Awesome. Thank you so much, Katie. That was awesome. Super interesting. So I'm just going to give a really brief explanation of how to make your own Constellation Lantern. So this is a really fun project that you can do at home using materials that you probably already have laying around the house. I think it's really pretty. You can use it as a nightlight in your bedroom or your bathroom or something like that. And it's just a really fun way to kind of learn a little bit more about the constellations. All right, so all you need are a glass jar or plastic jar, something clear with the labels removed. You're going to need a light source. So here you can see that I have a headlamp, but you could use an electrical tea light or a small flashlight, whatever you have. You also are going to need something to punch the holes, punch your stars in. So I'm going to use a pen, but you could use a pencil or a skewer or a like a toothpick or something like that. We're going to need some tin foil, and then I used cardboard to kind of protect my work surface. So the first thing that we're going to need is we're going to need our tin foil. So you're going to want a piece of tin foil that is about the height of the jar that you're going to be using. And you're going to want it to be also the length, you're going to want it to be long enough so it can wrap around the jar. So you can kind of test that by wrapping your tin foil around the jar and making sure that the ends meet. You don't want any light to be escaping out the other side. So at this point, you can kind of choose, what constellations you want. I would recommend choosing maybe 4 or 5 different constellations. So you can research online and find some sort of template like this one that I found to kind of help guide you as you're punching in your holes in your tin foil. There's plenty of templates. You can print something out and kind of overlay that template on top of your tin foil and then just punch straight through both the paper and the tin foil. Or you can kind of just eyeball it and kind of estimate. That's what I did here, but either way is great. As you can see here, kind of in the upper left-hand corner, you can see that I did my a Big Dipper here. I would caution against going too high up here. I would almost even say, keep your constellations in this lower half because you don't want your constellations to kind of be cut off by the top of the jar. So when you're planning where you're going to put your constellations on your lantern, I would recommend keeping them in this bottom half or kind of 2/3 of your tin foil. But yeah, then it's super simple. All you do is you take your pen and you just punch holes directly through the tin foil on top of your cardboard in the pattern that you want your constellations to be. And once you've put all of your constellations onto your tin foil, then you're ready to start assembling your lantern. So you're going to take your tin foil, or you're going to roll it up, and then you're going to insert it down into the jar. What you can do is you can kind of take your hand and sort of help press the tin foil up against the sides, kind of smooth it out from the inside. You can see, some of my tin foil sticking up here, but that's not a problem. Then you're going to take your light and you're going to turn it on, kind of get prepared, and then you're going to drop the light down into the jar. And once you put the lid on, then you've got your Constellation Lantern. So it's super easy, super fun. You can have a couple of these around your house. But yeah, it's a good way to kind of learn a little bit about your constellations. So I'm going to invite Katie back up here to join me, and then maybe Talia can check and see for us if we got any questions from our Q&A.
We do have some questions. So Katie, you were talking about using the North Star to calculate latitude, but we have a question about, can't you just use it sort of as a compass? Like, will it point you north? Is it in fact perfectly, can you use it as a compass?
Yeah, absolutely. So that's what's so great about the North Star, is that it never changes position. So as long as you can find it, then you know exactly where north is. And we're pretty lucky. We're living in a time where we have a North Star. It's just total coincidence that there's a star that happens to align perfectly or almost perfectly with Earth's axis. That's not the case normally. It's pretty rare that that would actually happen. But there is an interesting phenomenon that the Earth has or does where it wobbles. So over the course of 26,000 years, the Earth completes one wobble. So you can kind of imagine it like a top that's starting to run out of momentum a little bit, and it kind of looks like this. The Earth does that over 26,000 years. So if we're looking 12,000 years ago or 13,000 years ago, the axis of the northern axis of the Earth would have been pointed in a different direction. So they're actually, the North Star was not Polaris. So right now we just happen to have a star that aligns perfectly. And then in 12,000 years from now, there won't be, we won't have Polaris as the North Star anymore. It'll be closer to Vega, actually, the star that I mentioned that's in the constellation Lyra the Liar. But for our lifetimes and our purposes, yes, the North Star can always be used as a compass. It's a good question.
So another person has a question regarding, this is all obviously D-Day occurred in the Northern Hemisphere, but what about if you were trying to do celestial navigation from the Southern Hemisphere? Is there a star that you could utilize the way you can utilize Polaris?
So there's no star that lines up perfectly with the southern axis like that we do in the north. So that's a really good question. There isn't one star that you can use for navigation in the southern hemisphere, but what folks do use a lot of the times is a constellation called the Southern Cross. Which it's not directly in the south, but it's pretty close. And there are some other constellations around it where you can kind of almost triangulate where the southern axis is or where exactly south is just by looking at those three constellations. Something I forgot to mention during my presentation was the constellations in the Northern Hemisphere are primarily Greek and Roman, but a lot of the constellations in the Southern Hemisphere are actually named after celestial navigation tools. So there's a compass constellation and a clock constellation, telescopes, microscopes, all these really cool scientific tools. There's a sextant as well. So the Southern Hemisphere has a lot of cool stuff happening in the night sky.
And one final question, we have a question, is the North Star the brightest star? Because I know that's something that that tends to be a common belief. Is that true?
So the North Star is not actually the brightest star. It looks, we think of it being a very prominent star in the sky, but that's really just because it's famous and that it's in the north. If you were to list the top 50 brightest stars in the night sky, the North Star comes in at number 49, I think. So it's not particularly bright, but it is always in the north. The brightest star in the sky is called Sirius, and it's in the constellation Canis Major, which you can spot in the wintertime if you're up here in the Northern Hemisphere.
Thank you both so much for that presentation, and I hope everybody watching enjoyed this very unique team up between two great institutions, the Museum of Science in Boston and the National World War II Museum in New Orleans. Both do have virtual offerings for anybody who wants to stop by, and I'll put those websites up so that you can see them. In the meantime, Leah, Katie, thank you so much. If you guys want to do like a final goodbye and everybody give them a silent cheer.
Bye, everyone.
Hi, thank you guys so much.
And again, we really hope you enjoyed this special presentation. And if you would like to check out either institution's virtual offerings, you can do that at either of these websites. The Museum of Science also has a campaign called Science Matters, which is helping us keep our virtual presentations going. So if you did enjoy this presentation, please consider going to visit mos.org/Science Matters to help support our live virtual programming. Definitely check out what the National World War II Museum has on offer. And we hope that whether you're coming to us as a fan of the Museum of Science or the World War II Museum, you keep learning, because learning never stops. It doesn't matter what's going on in the world, learning never stops. So have a great day, everybody, and stay safe.